Hi guys, we're GasLEEK. We're all from UC Merced, and we had no clue what to do coming into this hackathon. But when we were driving here, we were noticing that gas prices were like 10 cents cheaper than last week. And we're like, damn, I should have bought gas this week and saved like $5. I don't want to pinch pennies and say that $5 is a big deal, but for somebody that's driving professionally, if they could optimize when they buy gas, that could make a significant difference in how much money they're saving. Of course, hindsight is 20/20. You don't always know what gas prices will be in the future. And that's why I thought it'd be a cool challenge today to use machine learning to predict what the gas would be in the future to help truckers or people that drive a lot save money when they're purchasing gas. So Dennis will talk a little bit more about how we use machine learning for this application.
Yep, so basically, with the data being the most important part of a machine learning model, I would say, first we had to find a legible data set. So we went over to the United States Energy Information Administration, I know it's a lot, and we pulled a time series from them. It's basically a time series going from around 1993 all the way to present time, and it's average gas prices. Our main approach for a predictive model was to use what is called persistence forecasting. This is basically the idea that you have a previous state in time, and this previous state in time can actually predict the next state in time. In our case specifically, this would be last week's gas prices predicting next week's gas prices. So in order to achieve this, we used a long short-term memory model, LSTM for short. This is basically a type of recurrent neural network which are actually very notably good for keeping track of long sequences of data and operating on that. Obviously, machine learning is definitely a pretty taxing tool. So in order to kind of optimize that, we were able to look to the cloud to do some heavy lifting for us, and Dan will actually touch on that right now.
Yeah, so we used Google Cloud Platform to train our model on the cloud. Instead of trying to run them on our machines, which would probably overheat them, we tried, and our CPU was running at like 200% somehow. Yeah, so after we had this training done, we have a fitted model where we can put in inputs of, like Dennis mentioned, previous gas prices from before and predict next week's gas price. We can do this multiple times to predict further in the future, but would reduce our accuracy. Being able to retrieve this data wasn't too hard because all we had to do was fetch the data from our API, and we would be able to then visualize and do computations on the data, which I will give to Brian to actually explain more.
Yeah, so real briefly, we have a quick React app that we're running. I hope everybody can see it kind of. So we have our current gas trend. It's been going down. Like I said, it was like 10 cents more expensive a week ago. Then we've projected gas prices, and we found that gas prices are, well, from our model, we're assuming that they'll continue to go down just a little bit. But that little, like a few cents, can still mean a lot if you're buying, let's say, 300 gallons of gas, like you're a trucker. So if you're buying 300 gallons of gas, we recommend that you would wait as long as possible and save around $40 for gas. And then we found an interesting trend where, if all truckers use this sort of machine learning, we predicted that they could save around $40 million annually, basically bargaining when they're buying gas based on our predictions. That's basically it.
All right, thank you.
I'm curious, did you test your prediction model against actual data to see how well it performed?
Yeah, so for our data set, we use the same data set, however, we split half into training and half into validation. We were able to test on our validation set, and we have about, it was like 0.05 mean squared error. So that was our results on that. As for a different, a different data set, we weren't able to use that.
So to translate that into people, if people don't speak machine learning, that means our data set was around 95% accurate. Of course, as soon as you start going to projected values, we don't really know. Maybe there's going to be a war in a few days that's going to throw off oil prices or something. But we're around 95% confident in the first data point that we generated, and then 95% for each next data point.
Are your only features the previous gas prices? Does this take into account like geography or anything like that? California gas versus Nevada gas?
So our data set was actually for California prices. So we do have data sets for other states, and we have like regional averages as well. But this our model was only training on the California set.
What's your tech stack?
Classic question. So for the machine learning guru, he's Keras and TensorFlow, and then front end is React.js and then Google Cloud Platform for our cloudless backend or cloud backend. Yeah, that's basically it.
Great, thanks guys.
Yeah, thank you.